Chapter 3, Section 3.4, Quadratics and Parabolas. Quadratic functions and the shape and uses of parabolas. A quick review to solving quadratic equations by factoring. To solve the quadratic equation ax squared plus bx plus c equals to 0, we factor the left-hand side and rewrite the equation in factored form. Px plus q times rx plus s equals to 0. We obtain the two solutions by solving each of the linear equations px plus q equals to 0 and rx plus s equals to 0. For example, to solve x squared minus 5x plus 6 equals to 0, we factor to obtain x squared minus 5x plus 6 equals to x minus 2 times x minus 3. Our equations become x minus 2 times x minus 3 equals to 0. We finish by setting each factor in turn equal to 0. X minus 2 is 0 gives the solution x equals to 2. X minus 3 equals to 0 gives the solution x equals to 3. Hence, the solutions of the quadratic equation is x equals to 2 or x equals to 3. Some quadratics are difficult to factor. For these, we need the quadratic formula. The quadratic formula. To solve the quadratic equation ax squared plus bx plus c equals to 0, we use the formula x equals to negative b plus or minus square root of b squared minus 4ac divided by 2a. If b squared minus 4ac is less than 0, then there is no real solution. For a certain population, the growth rate g in thousands of individuals per year depends on the size of n in thousands of the population. The relation is g equals to 1 plus n minus 2/10 n squared. The population is stable when it is neither increasing nor decreasing, that is, when the growth rate is 0. At what level is the population stable? Solution. We need to find when g is 0, which says that 1 plus n minus 2/10 n squared is equal to 0. This is a quadratic equation, but not written in standard form. We rearrange the terms and use the quadratic formula. Negative 2/10 n squared plus n plus 1 is equal to 0. N is equal to negative 1 plus or minus square root of 1 squared minus 4 times negative 2/10 times 1 divided by 2 times negative 2/10. Notice that here a is negative 2/10, b is 1, and c is 1. Then we simplify, and n is equal to negative 85/100 or 5 85/100. The negative solution makes no sense for population size, so we discard it. The population is stable when there are 5 85/100,000 individuals present. The graph of a quadratic function has a special shape known as a parabola. Note that y is equal to ax squared plus bx plus c. The parabola opens upward when a is positive, and downward when a is negative. A key bit of information is the location of the tip of the parabola, called the vertex. The x value of the vertex is x equals to 1/2 times negative b divided by a, or simplified, negative b divided by 2a. Example. A rectangular pen is to be constructed using the side of a barn as one boundary and 100 feet of fence to make the other 3 sides. Find the length and width of the rectangle that encloses the largest area. Area is equal to width times length, or x times y. Replace y with the expression 100 minus 2x. We have x times 100 minus 2x square feet. We need to find the maximum value for area, which is x times 100 minus 2x, or simplified as negative 2x squared plus 100x. The parabola y equals to negative 2x squared plus 100x opens downward, so the maximum value for the area occurs at the vertex of the parabola. The x value of the vertex is x is equal to negative b divided by 2a, or negative 100 divided by 2 times negative 2, or x is equal to 25. Therefore, to enclose the maximum area, we use x equals to 25 feet for the width. That leaves 100 minus 2x, or 100 minus 2 times 25 equals to 50 feet for the length.